trying to find a way of calculating the area of a triangle. Here are the vertices 0, 0 and 1, 1. This is 0, 0 and this is 1, 1. And basically the point of the first part of the investigation is to move C. So what we're going to do is we're going to go onto GeoGebra. And once we're on GeoGebra, we're going to plot this triangle. We're going to plot a point, so you select A as the point, 0, 0, 1, 1, and then we're going to plot a random point because it says what we need to do is plot several triangles like Eugene. So let's do Eugene's to begin with. His third point is at 5, 2. So let's move C so it's at 5, 2. We now need to join them with a line. So this is a line. We point A and then to B, and then we point B to C, and then C to A. And then we need to calculate the area. GeoGebra is really clever and it will actually work out the area for us. So what we do is we create a polygon. So we do A to B to C. And the way we do that is by clicking this shape here. And once we've clicked this shape here, we can create a light orange triangle. I'm going to go over how I did that again. So if I undo the steps, you can actually do this without the lines, but the lines are a nice addition. So if I zoom in, like I'm zooming in on a phone, and I click polygon, I click A, then B, then C, and then back to A again. And it gives me a triangle. Another way of doing it would be you could start at any vertex, B to C to A and then to B. And basically we want to look at the area, and the area is T1. So the area is 1.5. Now, we need to do this for lots of different triangles and complete this table. Suggest a rule that relates the coordinates of the third vertex and the area of the triangle. Basically, it's asking you if there's a pattern between this and the area. The more vertices you do, the more likely you are going to generate a pattern. Then you need to predict what's going to happen for something you've not calculated. And then you're going to show that it does happen. So the next part is going to be the following. It says vertices at 0, 0 and 1, 2. So for this, we're going to look at the following. Next, Eugene decides to keep two of the vertices fixed at 0, 0 and 1, 2. So you go back to GeoGebra, and we're going to have 0, 0 and 1, 2. So we're going to move the B coordinate. So you need to go back on yourself and just move the B coordinate. And you can see I'm having a problem here because I'm still on the polygon mode. So if I go back to this mode, I get off the polygon mode and I go onto the pointer mode, which is the moving. We can then move the coordinate up here. We're going to use the classic to plot several triangles with the vertices at 0, 0 and 1, 2. So we're going to just repeat the process of what we did in this table, but now with what it looks like here. Calculate area, summarise results, suggest a rule, make a prediction. Exactly the same as above. We then do it for 0, 0 and 1, 3. We then do it for 0, 0 and 1, 3. And then 2, 3. Now you can see here that I cannot see the whole investigation properly, so I'm going to go to the PDF version. And it says 0, general result for 0, 0, A, B and C, D. Use what you've discovered so far to suggest a rule for the area of a triangle with 0, 0, A, B and C, D. So A is going to be, for example, this would be A, this would be B, and then our new coordinate would be C and D. So there's going to be a relationship between the AB and the CD. And if you can't see it, you need to do some more work. Justification. So This is getting towards the last part of the investigation. Consider the following diagram. Use simpler formula to find the areas of rectangle ADCE. Well, we know what the formula for a rectangle is, and we know what the formula is for ABD and BDC. And the reason why is because ABD is not a right angle triangle, but you can split it into two right angle triangles. What I mean by this is ABD, you can split it into two right angle triangles. You can find the area of this triangle, and then you can find the area of this triangle and then add them together. This is what we mean by simple formula. And then we can prove that ABC is indeed 1.5. Now, I'm not going to go over too much more because this is for the top grade. And what we're going to finalise is talking about how you get your 7s and 8s. So make sure you achieve all of these things here. Once you finish your investigation, double check each of these criterions. Good luck, and let me know during the lesson if you need any help. You're going to have either 3 or 4 lessons on this.